Okay, well, yeah, a lot of firsts for me this week, including this conference. First time in Denver. So who here is from Denver? Okay, we got a couple people. Yeah, it's my first time in Denver. What else? First time in Denver, first time at FinTech DevCon. And I don't know how I feel about this last one, but yesterday an AI agent made me laugh, and I am both mortified, and I'm not going to share the joke because it's not going to be a good first impression, but yeah, it was really funny. Okay, so let's dive in today's session on how to build agentic workflows using Conductor. Conductor, just to give you a brief overview, is an open source workflow orchestrator. It was born at Netflix around 2016. And it has a lot of experience with building orchestration, so it's been battle tested. I'm super excited to explore with you today how we can leverage Conductor to build smart and autonomous, but the most important part, trustworthy workflows. A little bit about me. My name is Maria Shimkovska. If anyone is wondering, Shimkovska is both Polish and Bulgarian. I am a content engineer at Orkes. I have gotten a couple of questions about what a content engineer means. So basically what I do is I write code, build applications, and then write about them. So it's kind of like being a software engineer and a writer at the same time. And it's been my favorite job so far. Today's session is intended to be casual, so if you want to eat or drink something, go for it. It's developer to developers. I did spend a few years working as a developer. So yeah, feel free to be casual. It's always been my experience that those are kind of the best sessions when it comes to a learning experience. And my main hope for today, by the end of our time together, you're going to feel motivated and you're going to feel equipped to build your first agentic workflow, even if it's super simple. Because once you see it in action, you'll see how powerful and how fun they can be to build, especially when you have the right tools that make that possible for you. Just a couple more things. I have a lot of books at home, over 400. Need to get rid of those soon. I love to figure skate and hope to go to do some competitions in the future. And I love coffee, so that's why I brought one here to go with the casual vibe as well. Now, since today's topic is about workflows, I've structured this session kind of like a workflow. So you can think of it as breaking down a larger goal into smaller tasks, each happening in a certain order. We'll move step by step through 4 key parts that I've outlined. First, we'll cover why AI agents alone are not enough in production, and why integrating them into like a well-designed workflow makes them really powerful rather than just have a single one. Second, we'll introduce agentic workflows, what they are and how they combine AI agents with workflow orchestration. Third, we'll dive into why using a workflow engine, specifically Conductor, makes building, managing, and scaling these workflows straightforward and efficient, and my favorite part, fun as well. And finally, we will end with a practical demo. I built a simple demo to show you what a workflow like that would look like in Conductor open source. It'll give you a clear kind of hands-on look at an agentic workflow in action. Okay. Now, for this one, we all kind of seem to be having the same problem when it comes to AI, which is trust. If you've ever hesitated before trusting an AI system, maybe you've seen it confidently provide the wrong answer, hallucinate, or completely misunderstand simple instructions, you're definitely not alone. Anyone who has used AI, especially those customer-facing LLMs, has gotten annoyed. I for sure have, and a lot of my friends have as well. So how could we possibly put something as important as a financial application? How could we possibly put something, how could we possibly put AI in something as important as a financial application if we don't have that most vital part, which is trust? And that is precisely why we need something more structured, something more transparent and reliable to keep AI accountable and to keep it trustworthy. And you will hear me talk about trust a lot because this is the biggest kind of roadblock when it comes to a lot of financial institutions and financial companies, and also other ones that deal with important data integrating AI into their platform. And that's something is agentic workflows, at least with the current generation of AI agents, because I'm not going to claim that I know how they're going to look like in the future. All right, so section number 1, why AI agents alone are not enough. Short version, agents are great at reasoning and exploration, but production systems need more than reason about a plan and kind of hope for the best. So given our collective trust issue with AI right now, it's clear that simply deploying standalone AI agents is not enough. AI agents on their own often behave like black boxes, making decisions you can't easily track, control, or trust. They can be unpredictable, hard to debug, and challenging to scale reliably. And maybe you have, sorry guys. And maybe you've experienced this firsthand, just making sure we're on the right slide. An AI agent works perfectly fine when you're testing it, but then you put it in production and something inevitably goes wrong. Without clear structure and oversight, you're kind of stuck wondering what happened. Like, it worked in testing, but now in the real world, it's not behaving the way I thought it would. That is exactly why integrating AI agents into these workflows is so important. Workflows provide transparency, accountability, reliability, all of those things that are super important that standalone agents can't deliver. Okay, I have talked about AI agents, but the very important question is, what is an AI agent? Because when I first started learning about AI agents, I found that question very difficult to answer. It seems simple on the surface, but the reason why it's so difficult to answer is because so many companies, these big companies that are creating these LLMs, they all have their own interpretation, their own definition of an AI agent. So when I say agent, I mean an autonomous program that takes an input, thinks about it, reasons about it, usually with an LLM. With the current generation of AI agents, it's with an LLM. And then takes some sort of actions to execute using tools or APIs that you give it access to. I did put autonomous in quotation marks, if you saw that, because there is also the discussion of how autonomous those agents really are. A lot of people claim that autonomy can be on a sliding scale. And again, these agents also keep memory in store to have context or to have access to past decisions that the agent has made. And that's really powerful for exploration and for automation. But powerful is not the same as production ready. Let me actually ground this with a more concrete example that we will revisit in the demo at the end. So, because this is fintech, imagine a fraud analyzer agent. A user makes a transaction. The agent kicks off, enriches the data with some context, reasons through risk, and produces a simple outcome. Does it think it's fraud, or does it think it's not fraud? And how confident is it that it's fraud or not fraud? Super cool. At least I think so. In the demo later, I'll show you an agent like this one as part of a much bigger agentic flow. But even here, a lot can go wrong if this is just one agent in production. Give it a second. There we go. Okay, let me share 2 fun examples that may keep your teams kind of awake at night, afraid to fall asleep, or wake up in the middle of the night at like 2 a.m. And when I say fun, I mean simple, mundane, even boring mistakes, which ironically make them super dangerous. In the first scenario, an AI agent approved a mortgage, but no one can figure out why. There is no clear rationale, no transparent decision-making, just an untraceable, yep, that looks good to me from the AI. That's really scary. In the second scenario, an AI agent went beyond set financial limits simply because the prompt forgot to specify a cap. The agent didn't throw an error or trigger a warning. It just quietly made a very costly mistake. Notice these weren't traditional code errors either. No exceptions, no stack traces, only silent, very costly, incorrect human decisions. So what's missing here? The answer is simple. The exact things that any robust system requires: structure, visibility, safeguards, and accountability. Okay, so we've talked about agents making silent mistakes, but seriously, what could possibly go wrong? Well, quite a lot actually. Without guardrails, your agent will do exactly what you asked it to do, and it will also do everything you forgot to ask it to do. A missed detail in your instructions, in your LLM prompt, isn't just overlooked, it's quietly and confidently acted upon by the agent. Without clear visibility or audit trails, decisions become black boxes. Imagine trying to explain a questionable decision to a regulator or even your own support team when you can't trace how the AI got there. If your system is hard to debug, your teams start shipping slower. Or worse, they ship really quickly and cross their fingers hoping and praying that nothing breaks. And that is not sustainable. Without human oversight, cases that the AI isn't sure about or those that pose really high risk can quietly slip through the cracks as well. You might not even notice until it's too late. And again, importantly, none of these risks are unique to AI. They're just amplified by AI. These are risks present in any system handling money or sensitive data. But there is something very important about the time we are in right now. We are kind of at a tipping point. We're giving these agents more responsibility, more autonomy than we've historically given other programs. So even if your scope feels small, maybe it's just one smart agent in production, right? You'll quickly hit production challenges if you don't build matching controls from the start. Okay, single agents are fantastic, I'm not going to lie about it, at least until reality kicks in. They're really great at their one narrowly defined task, but then the messy, kind of unpredictable real world shows up and they start to struggle. Ambiguity, unclear paths, edge cases, these aren't just inconveniences in the AI world. They're exactly where errors and outages thrive. As soon as you start adding more prompts as well, tools or complexity to a single agent, its behavior quickly becomes unpredictable too. Like sometimes when you may have experienced when you're using ChatGPT, and after a while it starts hallucinating more than when it started. Its behavior quickly then becomes unpredictable. It becomes, again, that metaphor of a black box. Suddenly, you can't easily reason about latency. You can't predict cost or diagnose failure modes. And again, in production, this is not sustainable. You need clear, predictable systems, not mysterious black boxes. So what's the solution? It's not about making your agent bigger or more complex, right? Because we've established that that's not going to work. And I'm not even going to mention the token cost of that. It's about making your systems more clear, more structured, and more understandable, which leads us to multi-agent systems. This is a much smarter approach to build a multi-agent, to build an agentic system, which splits complex problems into smaller pieces, each handled by a specialized agent. I like to think of it as like a division of labor. Let's imagine fraud analysis is handled by one agent, then you have a claims resolution handled by a second agent, and then you have payment processing handled by a third agent, as opposed to one giant agent handling all of that into like a massive fraud detection super agent program. This simplifies each agent, making it easier to test, debug, and scale. So that solves part of the problem. You can add capacity or swap agents without disrupting the whole system. Let's say your payment agent is not working. You can easily rework that, no problem at all, and just plug it in. Or you want to add another agent to handle a different task, and you can do that as well. Think about these stereotypical like group projects that we've all endured. Each person has their clearly defined task, but without proper coordination, communication, or accountability, something will go wrong. Someone missed the deadline, someone duplicated work, or someone even dropped the ball entirely. Agents, whether they're a single agent or multiple agents, need the same thing that a successful group project requires. They need clear expectations, they need explicit contracts, they need built-in checks and balances, and a system to record of record to understand decisions. That's exactly where these workflows come in. They provide those essential guardrails, those safety nets. They provide the contracts, control flows, retries, auditability that ensures that your agent not only does their job well, but individually, but also works smoothly together as a cohesive team. Not team. All right, so to wrap up this first section about AI agents, single AI agents, and multi-agency, LLMs and agents are really, really cool. I personally enjoy working with them, but without scalability and security and compliance, without visibility, they don't survive contact with production. That's why we use agentic workflows right now. They give us the orchestration, they give us the guardrails, the auditability to ship with confidence. Okay. Next up, I'll define agentic workflows and how they solve these exact problems that we talked about in the first section. And before we move on, actually, I wanted to show you what a workflow could look like. So if you can see, let me move my mouse. You can see here, this is just a series of steps that happen in a certain order. So when I'm talking about workflows, this is what I want you to imagine if you're not familiar with workflows. When I say agentic workflows, that just means you add some sort of agentic component, whether it's a simple LLM or whether it's an entire AI agent into your workflow. Okay. So yeah, I hope that helps. Okay, so again, when I talk about an agentic workflows, here's what I mean. It's a workflow designed specifically to, and I'm going to use the word orchestrate, but when I say orchestrate, it's just kind of communicating, making things fit together. It's a collaboration between AI agents, humans, and traditional systems. You can think of it as like a conductor orchestrating different musicians in an orchestra. So it does that cleanly and predictably. AI agents are excellent, again, at reasoning and decision-making and handling complexity. But left unchecked, their reasoning can easily go off track, becoming very unpredictable and even invisible. Workflows act as guardrails. They make sure an agent's reasoning stays within clear boundaries, is easy to observe and understand, and most importantly, is recoverable if something unexpected happens, because again, things will happen in production. Okay, so you might be wondering, all right, but why add this workflow layer if multi-agency already works, right? Isn't this just adding extra complexity? And the answer is simple. Agents, again, function well in isolation, but production demands that reliability, that visibility and control. Agentic workflows provide exactly those elements, ensuring your agents don't just run, but they run safely and predictably. That predictability is, again, super important in production and effectively at scale. And again, all these are, again, vital in industries like fintech. Okay, so let's look at a high-level pattern that we'll use throughout this talk for building agentic workflows. So first, we have, like something happens, a trigger, like I buy this cup of coffee, and the company receives, Starbucks, let's say, receives a new transaction. Then one or more agents step in to reason about that trigger, analyze it, and taking initial actions. If an agent isn't confident or detects high risk of fraud, the workflow proactively loops in a human, like a real person, expert, to validate and correct and guide the decision of the workflow. And finally, the workflow commits a clear decision: approve, flag, escalate, or enrich, whatever the outcome demands. To ensure that reliability, scalability, and transparency, we add that orchestration component, using a workflow engine like Conductor to handle complexity, errors, retries, and monitoring, so that you don't have to do that in-house. Okay, so we've established that we need structure, and that's where orchestration comes in. Another way to think of orchestration is like a control plane. Its job is to coordinate your agents, to enforce the right order of tasks, and explicitly manage trade-offs, whether those handoffs are to another agent, a human, or a traditional system. Orchestration also ensures your workflow consistently applies business rules that your company may have, so your decisions always align clearly with the policies and regulations that you have. And again, these business rules can be applied, the way I think of them is like if-else statements, just to make sure that you don't have to use an LLM and use an agent for those, but you do want them in your workflow, especially an automated workflow. Okay. Well, now you might wonder, why go through all this effort to orchestrate, right, rather than just chaining together more prompts? That could also work, theoretically. Well, with orchestration, you gain explicit visibility and accountability and control. You're no longer hoping your agents behave. You know exactly how they're interacting. You can reliably manage complexity, and your team can easily audit, debug, and scale. And if you're using the right tool, you can do that visually, which is insanely helpful. And crucially, you can seamlessly incorporate humans into the loop whenever there is uncertainty, risk, or you have that need for an expert judgment. Expert? Okay, so what is human in the loop? Kind of went over it, but I want to say human in the loop is not a last-minute patch. It's a designated checkpoint that should be thought of and thoughtfully put into your workflow. When confidence that something is fraudulent is low, the workflow can route to a reviewer with all of the context that the AI agent may not have or may struggle to get. And again, this is crucial for compliance and fairness and very important customer trust, especially when decisions affect money movement and credit. Okay, so next up, I'm going to talk about these business rules that I mentioned. These are the other side of the responsibility control. Okay, so business rules, just a couple of examples of what that might be. Like, you might want to flag all transactions over 200,000 to be reviewed by a human. You may not want the agent to make that decision for you because it's too high risk. Or if there is fraud probability of over 80%, you may want also a human to review that as well. These are just examples. You can come up with any business rules that your company may have, and it'll apply. Now again, business rules encode your policy, limits, thresholds, allowable actions. They keep behavior predictable and explainable. So when an auditor asks you, why was this approved? You can show the rule hit, the agent's rationale, and the human approval if it escalated. Okay, but again, can't we just add more agents and skip the whole workflow piece? I mean, I'm sure we can code that and put it together, right? Again, even in multiple agents, if there is no orchestration, and they pass messages kind of ad hoc, you lose the state, and no one has a single pane of glass, a single place to know what happened. An agentic workflow gives you a central coordinator. It tracks state, enforces those rules that you have, it routes to people, and it gives you this really vital end-to-end observability. Okay, so let's connect this back to our running example so it's more concrete. In a fraud flow, an event triggers an analysis. The agent, again, then enriches with more context and proposes a risk score. Rules check caps and thresholds. If the risk is high or confidence is low, it then can escalate to a human being. The workflow records every step, the input, the output, the rationale, so that later we can replay and explain the decisions that were made. You see this pattern actually live in the demo. Okay, so now that we've defined agentic workflows, how do we make them reliable and repeatable? And again, that's where the workflow orchestration engine like Conductor comes in. And that sends us nicely into section 3. Now, if section 2 was about what we orchestrate, this section is about the machinery that makes that orchestration happen. A workflow engine gives you reliability, visibility, and control. You can't get from ad hoc glued code, so you don't reinvent orchestration. Agents are great at reasoning and taking actions, but again, production, it needs that durability, it needs that traceability and control. And the specialized workflow engine, which would be a tool, is the control plane that wraps these agents with state, retries, those safeguards, guardrails we mentioned, and a full audit trail. And it makes it super easy to work with as well, especially when you have a really solid UI like with Conductor. Okay, but what does the workflow engine actually bring? Okay, let's define what exactly a workflow engine brings to the table, especially for agentic workflows. First, again, it provides those guardrails. You have your typed inputs and outputs, schema validation. You have built-in policy checks. This prevents your agents from drifting into unexpected and undefined behavior. Secondly, your workflow engines maintain durable state. This means that even if there's a crash or deployment, you don't lose progress. You can resume mid-workflow. You can even replay workflows with the exact same inputs, which is perfect for debugging and auditing if you want to know what happened. Third, this is one of my favorites. Decoupling lets you swap out agent's model or provider without rewriting all of your orchestration logic. So let's say you're using one LLM, but suddenly you're like, you know what, I don't want to use that one. I want to use another one. So that makes it super easy to swap it out with a different one. This gives you flexibility, and it saves you significant engineering effort as well. So we have our retries and timeouts, which are also super important. So this makes error handling straightforward and consistent. And again, I know I mentioned that the decoupling is my favorite, but this must actually be my favorite. Workflow engines provide built-in UI and audit trails, offering your teams and you and auditors kind of like a single trusted source of truth. Everyone can clearly see. They can see what ran, why, and with what data. Okay. Now you might be thinking, again, sure, but couldn't we just build this in-house? Couldn't we just code all of that ourselves? I mean, engineers are really smart people. They can do a lot. And technically, yes, you can. You can do that. But why would you? Workflow engines like Conductor, they handle these complexities. They free you to focus on building better agents and solutions rather than reinventing these critical but standard pieces. And so here I'm going to introduce Conductor, which I am using for the demo. Conductor OSS, it's an open source workflow engine originally built at Netflix. So it's been battle tested at massive scale. You define your workflows in JSON very clearly or visually through the UI. Then you register workers, which are like you can think of workers as like your apps or anything that you want to plug into your agentic workflow. Conductor then manages state, retries, timeouts, and monitoring automatically for you. It's specifically designed for decoupled services, making it straightforward to slot in AI agents as just another task in your workflow. So this is really important and very helpful if you're building multi-agent workflows. So in short, again, Conductor moves you from, oh, I have this like really cool AI agent to fully battle-tested, production-ready system, the same reliability that actually Netflix trusted at global scale. So it's perfect for the financial industry. Okay, so if you actually remember just one thing from this talk, I want it to be this. Again, don't reinvent orchestration because there are teams dedicated to working on this problem. So yeah, use the workflow engine. Conductor open source is free to use. So yeah, use the workflow engine to make your agentic workflows durable and scalable, and again, very important, trustworthy. Keep agents focused on what they do best, which is reasoning and tool use. Let the workflow engine handle all the tricky parts, so like managing your state, enforcing the control flow, providing those safeguards that you need, and ensuring just everything runs smoothly. So yeah, this is kind of how you move from an interesting experiments to dependable, reliable systems, systems that regulators or your clients, customers, or even your own like on-call engineers can confidently trust and be happy with. Okay, so we are at 35 minutes. Now let's put all of that into action and look at the agentic workflow we've been discussing throughout the talk. Okay. So for the demo, I kind of wanted to show you what an agentic workflow would look like in Conductor. So I built a simple application just so you can have a visual. I plugged it into Next.js UI so that it gives you that like end-to-end idea of how that could work. All right, now let me see how to do this. So give me a sec. I can't move it. Oh, I'm trying to move my tab to the next screen, but it doesn't want to select it. Not to worry, we've got help coming. Yeah, so what you're going to see is just like my React. I just move this like to the side, but I can't seem to select it.
Oh yeah, I'm having trouble too.
Okay, no worry. But while that's happening, I'm actually going to.
Do you want to try mirroring it again? Are you done with most of the slides?
There will only be one more slide at the end. But I mean, no, it's not necessary, but you can try this one.
Yeah, I can't grab it either.
Okay, let me try something else. Okay. Is that 3,000, guys? I can see. Okay, thank you. There we go. Perfect. Okay. So what you're seeing here, I'm seeing it on my screen on different tabs, so let's see how it goes. So this is a AI fraud detection platform that I built. It's just the UI, just to give you an idea. Now, I'm going to quickly walk you through what these components are, because I realize it's like new and can be a lot. So first, we have a transaction simulator. So that's going to simulate a transaction. Just like any transaction. Let's say I want to buy coffee. And so for the sake of this example, I just added like a simulator for it. I am going to skip this one actually and go down a little bit to this customer profile and risk context. So this just gives you more information on the customer. So if you have a transaction that you want to know whether or not it's fraudulent, then you need some context. You can't just get the transaction. An agent, you pass the transaction to an agent and you say, hey, is this fraud or is that not fraud? The agent can't decide because it needs some context. So This in the demo provides the agent with some context. So data from this section is passed along with the transaction that we're going to simulate, and it all goes into the workflow so that the agent knows what to do. Okay. So this is one part of the workflow. Actually, this is going to be a little bit harder than I thought because I need them side by side, but we'll see. Okay, so before I make a transaction and show you how it all works, I do want you to get familiar with this because we are going to look at it, and yeah, I don't want you to be confused. So this is Conductor, OSS, and this is the workflow that I'll be using that is connected to the front end. So you define all of your tasks in JSON, like I mentioned, on one end, right here on the left. And then on the other end, it shows you visually what that workflow looks like. I mean, I can't read from here, but you can see, I believe this one parses the input so that it, instead of strings, it turns it into a JSON format so that the other tasks can know what to do. And so, yeah, it just logically flows. And so here's where you build this workflow. Now, an important tab, I'm not going to walk you through the entire Conductor UI. I'm just going to show you the important bits here. We go to executions, and this is where where our execution is going to pop up. And now, if I go back to my demo, which I believe is this one, there you go. Okay, so if I click on select merchant, I have some merchants here that I pre-populated. Again, I am a big fan of coffee, so let's go with DevCon Coffee Co. I paid about, here in Denver, I'm paying about $9 per coffee, I know. And location, Denver. And this is in person. And also, if I scroll down, you can see somewhere that my location is in Denver. So there you go, Maria. I'm the user, and my location is Denver. So yeah. So this looks like a good, like straightforward transaction. Okay. All right. So I'm going to execute that transaction, and the agent, you can see here, is thinking. It's thinking. Okay. So what this does is it goes step by step, and I think a better a better view is here. So I'm going to refresh and get the latest. Okay. So this is the transaction that we just ran. So we see the transaction goes step by step. It went this task, then as defined, it went to the next task, to the third task. And here is interesting because here it has to make a decision. So you have this switch task. Default, like the transaction looks fine, and you can send it to a payment agent, so for processing, and the transaction is fine. And here you want it to be. Let me make that a little bit bigger. Yes. So here you want it to be reviewed by a human. This transaction was super simple. It was low cost. It was in a location where we are located, Denver. So it went to the default case. So if we scroll down through this workflow, we see that it just went to the next one, to the next task. It finalized the fraud analysis, and it went to payment agent. And the reason why it's buffering is because for this demo, I'm just showing you one agent, and this is just the second agent. But yeah, after this agent does its work, it'll then complete, and the transaction, you can implement any kind of logic you want, like inform your user or stuff like that. Okay, so now there's also another task which we can make. If I go back to here, okay. Now, let's say we choose a high-risk merchant, right? And it's a very weird transaction. $50,000, I hope that's 50,000. And it wasn't made in Denver where we are. It was made in San Francisco. And we execute that. What's going to happen? Okay. So, we get this thing. That looks new. So, okay. Let's go to the workflow and see what's going on. And that shows that visibility. I believe this is the last one. Okay. So again, same process as before. We go through all of the tasks that I've predefined. And then again, we hit this switch, this like decision maker. And, look at that. It's buffering and it's waiting on a human reviewer. Okay. So with this is the human in the loop that I was talking about. This is where an automated workflow provides those guardrails. So something weird like that transaction happened, you can loop in a person instead of hitting that payment agent. So if I go back to here and I click on, I'm the reviewer, let's say. I click here. And so I get some information here about the transaction. Again, in a live application production, you're going to make this much prettier, but this is just to give you an idea. It gives you some values of what the transaction looked like, and some information so that you, as the user, can decide whether to approve or decline it. Let's say you want to decline that. Okay. Oh, whoop, there you go. Now, something happened again as soon as I hit approve. So let's see. I click, I hope is that refresh? Thanks. Okay. So, oh, look, see, it passed. And then it goes down. It goes down, another switch. And because we denied, so we denied that transaction, it then goes into a different section. If we approved it, it would have gone into approve. And this is where you can build different logic. What do you want to do? What do you want to happen when it's approved? Now, if I scroll down, we hit this claims agent. And this is where you can build out that second agent. And you can, anything that you want, like anything that a claims person could do, the agent could do, and you can build out your logic within this agent. This is just to show that you can slot that agent in your agentic workflow. And depending on how that goes, that will continue to flow into this last step, which is to just terminate the entire workflow. Okay, so this is basically what the example was. I just wanted to show you what this looked like visually when it's connected to a UI rather than just being a workflow on its own. Because again, in the real world, you will have that connected to a UI. Okay. All right, so about this demo, I showed an agentic workflow that includes different AI agents. So they have we have three different AI agents. We saw the first one, which is like the main one, the analyzer. It analyzes your transaction and it decides, is that fraud or is that not fraud? And then you have that payment AI agents that you can slot into your workflow at the appropriate moment. And you also have your claims agent as well. So we also saw that we can escalate to a human and what that would look like. So we have full control over what will happen to that transaction. If it looks wonky and weird and just dangerous, we can just say, you know what, no, I don't want to approve that, and you can decline it. Or if it looks fine and the agent was just confused for some reason because it can happen, you can just say, still approve it. So again, that builds trust and provides visibility, which is, I put my fave. Again, it uses Conductor OSS to put it all together, so it's free and it has been battle tested at like a large scale. So you don't have to worry about that in industries like finance, where that is really important. So the main takeaway there, I wanted to put 3 points. Again, agents alone are not enough in production. Simple. Orchestrating them into workflows is super important, and it solves your production pain of incorporating AI agency into these tough industries like fintech. So you can use AI without waiting for it someday to be trustworthy, because that day again may never happen. Makes them easier, makes them safer and scalable, And again, workflow engines like Conductor make that possible to build super easy. So you don't have to reinvent orchestration. You don't have to build that in-house. And then if something happens with your in-house orchestrator, you have to split your engineering team into fixing that or fixing other problems that your core product is. Okay, so I know our time is over, sadly, womp womp. But what now? So you can go to GitHub, Conductor OSS, and we have some really cool projects that people have built with Conductor, and you can look at them. I will put this one as well up there, so you can experiment with it. You can look through, like, you can look at the workflow itself. You can pass in different transactions and see how the workflow handles them. You can break it and let me know, hey, I just broke your workflow, and that would be also fun. And I put the Maria Shimkovska. I could not find an icon for LinkedIn, but that's my LinkedIn. So I do write a lot about agentic stuff, and that's primarily like my job at Orkes, and it's what I love doing. And so yeah, I build these workflows and write about them. So if you were curious about what I'm writing and posting, you can follow me on LinkedIn. And I'm chronically on LinkedIn, so like I will respond if you have any question at all. So yeah, thank you so much. This has been really fun. Oh, and if you have questions, let me know. And there's a mic over there. And if you don't, that's totally cool too. Go for it.
How do you compare Conductor with LangGraph or other similar technologies?
So the question was, how do we compare Conductor with LangGraph and other ones, right? Right. So I haven't used a ton of them, but my experience with Conductor is that it's, again, really easy to set up and really easy to get going. It's also, and it also has that experience being used at Netflix, so it does have that trustworthiness of being used at scale. So you can use it for production workflows. So yeah, in my experience, when talking to other people, it can handle stuff like parallel executions, which I didn't dive into this talk, but yeah, and it's, again, very simple to use. And again, visual, which is vital in my experience, especially if you're just starting with orchestration and you just want to understand it rather than beat your head against the wall and trying to understand what's going on. Thank you.